Hi, my name is Phys and this is the Physics 2212 Lab 4 report video. And today I will be presenting this lab on the distance dependence of the magnetic field of a bar magnet. So as you can see on the slide, the lab objective was to measure the magnetic field of a small bar magnet at different distances, determine the distance dependence experimentally, compare measurements to theoretical predictions on axis and off axis, and estimate the magnetic moment of the bar magnet. And we also measured the off-axis field at a 45-degree angle. That was mostly using the code. For this experiment, we used a small bar magnet, an app on our phones called a Physics Toolbox magnetometer, a ruler, and a tape. And also an Excel spreadsheet to record and then analyze the data. As you can see from the picture on the right, the smartphone was first aligned with the Earth's magnetic north so that the X component of the Earth's field was near zero. The bar magnet was placed along an east-west ruler, and the exact location of the magnetometer sensor on the phone was determined to ensure accurate measurements. Maintaining the phone orientation throughout was very critical. As you can see from the spreadsheet, for the on-axis measurements, we measured distances where the X component of the magnetic field was 20, 70, 120, 170, and 220 microteslas. 3 measurements were taken for each distance and recorded in the spreadsheet. The spreadsheet was then already coded to calculate the average of both to give out a plot. And the slope of this plot gave the experimental value of n, which describes how the magnetic field decreases with distance. The intercept gave logarithm of k, which we use to calculate the magnetic moment of the bar magnet. And on the next page, you see a code, and our results agreed reasonably well with the theoretical predictions for a dipole field. And in this code, you can see that there are 2 arrows that are orange. Those are used to depict the magnetic field of the bar magnet going from south to north, while the blue arrows are meant to show the magnetic field perpendicular to the magnet going from north to south. And this was mainly for the off-axis measurement for when the phone was positioned at a 45-degree angle from the magnet's axis. And the measured and predicted values from this code, while they were a bit off as compared to what we got from doing the actual experiment, they matched a bit close to each other. And those are in the abstract for this lab report. Now for the what if questions. What if I hadn't oriented the experiment to compensate for magnetic north, and what if I stuck two identical magnets together end to end? Firstly, for the first question, if the experiment was not aligned with magnetic north, the Earth's field would interfere, causing an offset in measurements and underestimating the slope n, meaning that the only way this experiment could work properly and give you accurate values is if you compensate for magnetic north. And secondly, if two identical magnets were stuck together, the field magnitude would increase due to a larger magnetic moment, but the distance dependence n would remain the same. In conclusion, the experiment successfully demonstrated that the magnetic field of a bar magnet decreases with distance according to a power law. We determined the distance dependence exponent n, estimated the magnetic moment, and verified off-axis measurements. The results agreed with theoretical predictions, meaning the objectives of the lab. Thank you.